Hello children, how are you? I hope you all are happy and healthy. Well children, in the first part of this chapter, we saw how a quadratic polynomial can be easily converted into a quadratic equation. We also saw the standard form of the quadratic equation, and we also tried to identify a few of them. And after that, we also formed a few quadratic equations of our own. I hope you have understood it all and have also practiced it well. So today we will look at some methods of solving these equations. But before that, let's solve some questions here. Let me also know how much practice have you done. So here we have some numbers and we need to find out two such numbers whose product is this and whose addition or subtraction is this. So first is 324. Now how can we do that? First we will have to factorize it. We need to find the prime factors of 324. So let's do it. Dividing it by 2, we will get 1, 6, 2 here. Then again dividing by 2, we will get 8 and 1. Now we'll divide it by 3 and get 27. 3 again, 9 here, and again 3, and we will get 3 here. So prime factors are 2 multiplied by 2, multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. Now we need to form two numbers whose addition or subtraction is this. So if we take 3 into 3 into 3, that is 27. So, and here 3 2s are 6, 2s are 12. So 12 and 27, that would make 45. So if we take 3 3s are 9, and here 3 3s are 9, 2s are 18, 2s are 36. So 36 plus 9. Does that make 45? Yes, it does. So our two numbers will be 36 and 9. But look here, we need a minus 45, a negative 45. So for that, we will take both these numbers as negative ones. So minus 36 minus 9 will make 45, and their multiplication obviously will make 324, and that too positive one. So these are our two numbers. Let's look at the next one now. So our next number is 182 and 27. So product should be 182 and addition or subtraction should be 27. So we will first find out the prime factors of 182. Dividing it by 2, we get 9 and 1. Now dividing it by 7, we get 13. So its prime factors are 2 multiplied by 7 multiplied by 13. Now we need the sum as 27. So leaving 13 like this only, 7 2s are 14. So 14 plus 13, will it make 27? Yes, it will make 27. So our answer will be 14, 13. So these two are the numbers. Now let's look at the next one. Here we have 182 and minus 27. So this time we need the addition as minus 27. So what can be done? Taking the same numbers, if we take the negatives of these two, minus 14 and minus 13. So it will give us minus 27 and their product will be still 182 because minus multiplied by minus gives us plus. So our answer will be minus 14, minus 13 here. Let's move further. So now we are ready to look at the first method of solving these equations. It is called factorization method. Now if you are able to do this, then you will be able to use this method also. So let's start. So our first equation is this: 2x squared minus 5x plus 3 equals to 0. We need to solve it. That means we need to find out its roots. Here one thing you must know is finding out the zeros of a polynomial or finding out the roots of a equation is one and the same thing. So let's do it. For this we will have to find out AC first. AC here will be A, the value of A multiplied by the value of C. A here is 2 and C here is 3. So AC will be 2 multiplied by 3 is equal to 6. And B, the value of B here is minus 5. Now we need to find out two such numbers whose product is AC, that is 6, and whose addition or subtraction is B, that is minus 5. So for that we will find out the prime factors of 6, and that will be 2 into 3. Now can 2 and 3 be made into minus 5? Yes, if we take minus 2 and minus 3, that will add up to minus 5, and its product will be minus 2 into minus 3 equals to 6 only. So our two numbers will be minus 3, minus 2. Now we can split this middle term into these two, and we can write here 2x squared minus 2x minus 3x. We have just split this term into 2, minus 2x minus 3x. Now if we add it again, we will again get minus 5x. So we can write like that. After that is plus 3 equals to 0 here. Now we have got 4 terms here. Now looking at these two and then these two, we can take out 2x as common from these two terms. And thus in the bracket we will have one x, then here minus 1, because 2x has been taken out, so 1 will be left here. And from the next two terms, we can take minus 3 as common. And here we will have x and minus 1, because 3 has been taken out, so inside we will have minus 1, because this minus will get multiplied by this minus and will again make a positive 3. This will be equal to 0. Now we must check here, the factors in the bracket should be same. Here we have them identical, so these again can be taken as common. So here we will have x minus 1, and in the next bracket we will write 2x minus 3 equals to 0. Now taking this bracket to be equal to 0, we will see that value of x will be 1 here, and assuming this to be 0, the value of x here will be x is equal to 3 upon 2. So thus we get two roots, x equals to 1 and x equals to 3 upon 2. That's the way of solving it. Let's see one more example. So here is our next example. X square minus 3x minus 10 equals to 0. Now first of all we need to find out AC. AC here will be, here the value of A is 1 and the value of C is minus 10. So minus 10 multiplied by 1 will make minus 10. Now B, the value of B here is 3 or minus 3. It's minus 3. So we will write minus 3 here. Now we need two such numbers whose product is minus 10 and whose addition or subtraction is minus 3. So factorize 10, we get 2 and 5. So 2 and 5, can they make minus 3? Yes, they can make if we take one of them to be negative. So which one we should take negative? I think minus 5 and plus 2. If we multiply this, we will get minus 10 here, and if we add them, we will get minus 3. So our two numbers will be minus 5 and plus 2. So now we can split this term into these two. We will write x square minus 5x plus 2x minus 10 equals to 0. So this term has been split into minus 5x plus 2x. We can do that. Now looking at these two terms, we can take x as common, and in the bracket we will have x minus 5. Similarly, out of these two terms, we can take out 2, and in the bracket we will have x minus 5 equals to 0. So we must check here that these two brackets should be identical. So here we have, so we can take them as common, and in the next bracket we will have x plus 2 equals to 0. Now equating this bracket to 0, we will get the value of x as 5, and equating this bracket to 0, we will get the value of x as minus 2. So we have got two roots, 5 and minus 2. So I hope you have understood it well. But can you tell me now, why do we call this method as factorization method? This is because we have simply factorized the equation into two linear factors, and we have equated them to 0 to find out the roots. That's why we called it the factorization method. Okay, so now let's see a few more examples of factors. Let's look at this one now. So first of all, we will need to find out the AC. AC here will be minus 6 multiplied by 2, that is minus 12. And B will be 1 only, because coefficient of x here is 1. So now to find out two numbers whose product is minus 12, we will factorize them and whose addition should be 1. So we can simply take 4 and 3. So 4 and minus 3 will give us 1 as addition and minus 12 as the product. So now we can split this term as 4x and minus 3x. So 2x square plus 4x minus 3x minus 6 equals to 0. Now taking 2x common, we will have x plus 2 here, and minus 3 is common, and we will have x plus 2 here. We will write plus here because minus 3 has been taken as common, so inside we will get a positive sign, because if we multiply it again, we will get minus 3 multiplied by 2 will again make minus 6. Now these two brackets are identical, so we will write x plus 2 here, and in the next bracket 2x minus 3. Now equating them to 0 one by one, we will get x as minus 2 and here we will get x is equal to 3 upon 2. So our two roots are minus 2 and 3 upon 2. Let's see another example. So look at this one now. I hope you remember this one. This is the same equation that will give us the length and breadth of that park. You remember? Okay, so here, so first finding out AC, we will have to multiply minus 528 by 2 and we will get minus 1056, minus 1056 and the value of B here is 1 again. So factorizing 1056, we will get, dividing it by 2, we get 5, 2, 8. Again, so now we get 2, 6, 4, once again 1, 3, 2, once again 66, then 33. Now dividing it by 3, we get 11. So prime factors here are 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2, then multiply by 3 and multiply by 11. So now we need 1 as the addition or subtraction. So 11 into 3 is 33, then 66, I think that will be too big. So 33 here and 2 2s are 4, 2s are 8, 2s are 16, 2s are 32. 32 here. So 33 minus 32 will give us 1. So I think the two numbers here will be 32 and 33. Plus 33 minus 32. So x can be expressed as 33x minus 32x. 2x square plus 33x minus 32x minus 528 equals to 0. So looking at these two terms, we can take out x as common and we will have 2x plus 33 inside the bracket. And from here we can have 16 as common and here we will get 2x plus 33. Again we will have plus sign here because when it will multiply it by minus, it will make minus 528. Again these two brackets are identical. So 2x plus 33 here and in the next bracket x minus 16. Now equating this bracket to 0, we will get x is equal to minus 33 upon 2 and here we will get x is equal to 16. So these are the two roots. So well children, if you find this method difficult, that's okay because with some practice you will be able to use it easily. But still if you don't like it, then we have two more methods for solving these equations. And usually these two methods are thought to be very difficult. But when you actually use them, you will get to know that they actually make our calculations very easy. So let's see them. So for the first method, look here. Here we have two equations. Now you have to solve them. So which one do you find easier to solve? Which one do you think you will be able to solve easily? I think this one, this you can easily split the midterm and then you can make the factors, right? And this one is looking a little odd. But let's try to solve this one. This one you can do. So here x plus 2 square. Here we have minus 9, so we can take that to that side. It will become plus 9. Now here we have the whole square of this bracket. Now if I leave x plus 2 here and take the square that side, it will become under root of 9. So x plus 2 equals to under root 9. That means 3. Once plus 3 and once minus 3. It will give us two answers, plus 3 and minus 3. Now suppose the answer is 3. So in that case the value of x will be 3 minus 2, that is 1. And if the answer is minus 3 here, in that case the value of x will be minus 3 minus 2, that is x will be equal to minus 5. So did you see how easy it was to solve this one? This is because it had a whole square. Now taking the whole square to that side, we can easily get the solution. So if we find out some way of converting such an equation into this form, then can you imagine how easy our job will become? So for that, let's first solve this one. Try to open the bracket and we will solve this one. So here we have x plus 2 whole square. Now it is of the form of that identity that says a plus b whole square is equal to a square plus 2ab plus b square. Now using this identity, putting the values, we will get here x square plus 2 into x into 2 plus 2 square. That's what we will get, and here then minus 9 equals to 0. So solving this, x square plus 2 2s are 4, here we will have 4x plus 2 2s are 4 again, and minus 9 equals to 0. So we can write it like x square plus 4x plus 4 minus 9, that will give us minus 5 equals to 0. So see, did you see something? Did you notice? Now this equation is absolutely same to this one. X square plus 4x minus 5 equals to 0, x square plus 4x minus 5 equals to 0. So actually these two equations are same but in different form. So now let us look at some method of converting this equation into such an equation. There must be some method. Let's look at that. Now this method is called as method of completing the square. So let's start the method of completing the square. For that we will need to remember these two identities that says a plus b whole square and a minus b whole square, because we will use these two here. So I'm taking the same example. So x square plus 4x minus 5 equals to 0. Now our first step is to look at the a. The value of a should be 1 only. There should be 1 as the coefficient of x square. So here we have 1, so we can simply start. So we'll write it like this only. Next, plus 4x. So we can write that also here. And after that, we need to see the value of b. Here the value of b is 4. We will simply divide it by 2 and do its whole square. That's so easy. So it will be 2 and 2 square. We will just write it like this only. Now, this has given us a magic value. Now, this magic value will make our question very easy. What we will do here is, we will add this magic value once and then we will subtract it once. And we know that adding and subtracting the same value to a polynomial does not affect the polynomial. It will remain the same. So, we can do that. Here, we can simply add 2 square and then subtract it. And rest of the equation will be same, minus 5 equals to 0. Now, if we look carefully here, we will see that these three terms have become of that form, a square plus 2ab plus b square. We can write it like x square plus 2 into x into b, that is 2 here, plus 2 square. So, we see it has become a square plus 2ab plus b square, that form. And rest of the equation again same. So, 2 square can be written as minus 4 minus 5 equals to 0. Now, this can be converted into x plus 2 whole square. And here we will have minus 9 equals to 0. So, we got the same form of the equation that we saw earlier. So, let's try to do it with one more example. Here, what is the value of a? The value of a here is 9. Now, we need 1. So, to get 1, what we will do is, we will divide the whole equation by 9. So, we can write it like 9x square upon 9 minus 15x upon 9 plus 6 upon 9 and 0 upon 9. That we need not write because 0 upon 9 will give us 0 only. So, this 9 will get cancelled and x square minus 15x upon 9 will be written as 5 upon 3, 5 upon 3x, here 2 upon 3 and here 0. Now, this is our new equation. So, again we can write x square minus 5 upon 3x like this only. Now, we need to look at b. b here is 5 upon 3. We need not take minus here. So, 5 upon 3 will be multiplied by 1 upon 2. Dividing by 2 means multiplying by 1 upon 2, and thus we will get 5 upon 6. And now, we will write its whole square. Now, this is the magic number. We will add it here once and then subtract it here. And rest of the equation will be same. We do this to make the form here 2ab and the b square here. So, let's see now. Here, x can be written as x square and minus 5 upon 3x can be written as minus 2 multiply by x multiply by 5 upon 6. Now, on multiplying it, we will get 10 upon 6 and that will give us 5 upon 3 again, minus 5 upon 3x. Here 5 upon 6 square and rest of the equation 5 upon 6 square plus 2 upon 3 equals to 0. Now look at these three terms. This have become that form. Which one? Plus or minus 1? Here we have minus. So this identity. So this can be written as x minus 5 upon 6 whole square, because the value of a is x here and value of b is 5 upon 6. So we can write it like this, and rest of the equation 5 upon 6 square plus 2 upon 3. Now for solving it, we'll take these terms to that side. X minus 5 upon 6 whole square will be equal to 5 upon 6 square minus 2 upon 3. This plus 2 upon 3 will become minus 2 upon 3 there. And here 5 5s are 25 upon 6 6 are 36 minus 2 upon 3. Now taking LCM, we will get 25 here, and here 12 2s are 24. So this is equal to 1 upon 36. And on LHS we have x minus 5 upon 6 whole square. Now this whole square will go that side and become under root, and we will have x minus 5 upon 6 is equal to 1 upon 36 under root. So 1 upon 36 under root will be 1 upon 6. But once it will be of positive sign and next time it will be negative. So let's taking it like that. We can write here x minus 5 upon 6. If it is equal to positive 1 upon 6, then value of x will be 1 upon 6 plus 5 upon 6. That is 6 upon 6, that is 1. So value of x will be 1. And if we take it as negative, then value of x will be x is equal to minus 1 upon 6 plus 5 upon 6. That will mean 4 upon 6, that is 2 upon 3. So the value of x will be 2 upon 3 here. Thus we get two roots, x equals to 1 and x equals to 2 upon 3. Let's see another example. So our next example is 2x square minus 5x plus 3 equals to 0. Here again the value of a is 2. We need to make it 1. So we will divide the whole equation by 2. So we can write 2x square upon 2 minus 5x upon 2 plus 3 upon 2 equals to 0. 0 upon 2 will again make 0 only. This 2 will get cancelled and we will have x square minus 5x upon 2 plus 3 upon 2 equals to 0. Now we can write these two terms like this only, x square minus 5x upon 2. And now seeing the value of b, which is 5 upon 2, we'll multiply it by 1 upon 2, that is divided by 2, and we will get 5 upon 4. Now we need to whole square it. Now this term we will add once, 5 upon 4 whole square, and we will also subtract it once. And the rest of the equation 3 upon 2 equals to 0. Now looking at these three terms, we can write x whole square minus, we have the sign of minus here. So 2 into x into 5 upon 4. We can cross check it if it gives the same value here. 2 multiplied by 5 upon 4. So 10 upon 4 will give us 5 upon 2x again. And here 5 upon 4 whole square. Now these two terms can be taken there. 5 upon 4 whole square minus 3 upon 2. This can be rewritten as x minus 5 upon 4 whole square equals to 5 5s are 25, 4 4s are 16 minus 3 upon 2. Let's solve it further. Now for solving it, here we'll take the LCM 16. So here we'll write 25 and 8 3s are 24. So x minus 5 upon 4 whole squared equals to 1 upon 16. And x minus 5 upon 4 is equal to 1 upon 16 under root. Now x minus 5 upon 4 equals to 1 upon 4 plus and minus. If we take it to be positive, the answer will be x minus 5 upon 4 equals to 1 upon 4. So x will be equal to 1 upon 4 plus 5 upon 4. That will make 6 upon 4, that is 3 upon 2. And taking it to be negative, the value of x will be x minus 5 upon 4 equals to minus 1 upon 4. So x will be equal to minus 1 upon 4 plus 5 upon 4. That is 4 upon 4, that is 1. So the value of x here is once 3 upon 2 and then 1. So thus we find the roots of the equation. So children, this was the method of completing the squares. I hope you have understood it. There is one more method that is called the discriminant method or the quadratic formula. But that one we will do in the next part now. Till then, keep on practicing this and try to solve all the sums from your book. And we will meet in the next part now. Thank you. Have a nice day.